Okay, so last lesson that we did was about solving system of equations using substitution elimination. We talked about linear quadratic and then we talked about quadratic. So today we're going to learn about how to do this using a graphing calculator. So let's say this graph is given to you and they've said that parabola A has a vertex of -4, 4. So this is the vertex of parabola A, and one of its x-intercepts are -6, 0. Parabola B has a vertex of 1, -9, and their y-intercept is 0, -8. Both parabolas are graphed below. Determine the equation of each of the parabolas in the vertex form. Now this is something you did in the previous unit. When we're talking about the vertex form, let's split it up. And looking at the first parabola A. Okay, to solve this question, I'll have to substitute the values of my vertex into my vertex form, right? So y is equal to ax minus 4 squared plus 4. So y is equal to ax plus 4 squared, because negative times negative is positive, plus 4. Now I have a point -6, 0, and I'll have to substitute it into this equation to find the value of my a. So y is equal to 0, x is -6 plus 4 squared plus 4. So I have 0 is equal to a, -2 squared plus 4. -2 squared is 4a. Subtract 4 on both sides. I get -4 is equal to 4a. Divide 4 on both sides, and I get a is equal to -1. So I'm not done yet. I'll have to substitute this into this equation. So it will be y is equal to -x plus 4 squared plus 4. Okay, now find the equation of our B parabola. So y is equal to ax plus 1 squared plus -9. So it will be y is equal to ax plus 1 squared minus 9. To find the value of a again, I'll have to substitute 0, -8 into this equation. So y is -8, a 0 plus 1 squared minus 9. So I have -8 is equal to 1 squared, which is just 1. 9 minus a, so add 9 on both sides and you get 1 is equal to a. Now we substitute it into this equation because we're not done yet. Y is equal to x plus 1 squared. Oh sorry, this would be minus because the formula is minus, right? So -1 squared is still positive. So x minus 1 squared minus 9. And that's my second equation of my second parabola. So now we need to use technology to figure out what the solution of the systems of equation is. If you were to solve it using algebra, you could have done either substitution or elimination. But let's go ahead and use a graphing calculator for this. So y is equal to, let me just refresh my page. Your y is equal to is -x plus 4 squared plus 4, and my second equation is x minus 1 squared minus 9. And then I just graph it. This is what it looks like. I can look that there are 2 points of intersections. So second trace 5. My first curve is this. My second curve is this, and my guess is this. So my first point is -1 comma -5. I'll have to do the same for the second point as well. So this is my first curve, this is my second. My guess is somewhere over here. This -2 comma 0. And that's how you do it. So second trace 5, and my point of intersections were -2 comma 0 and -1 comma -5. So in multiple choice questions or numerical response, when you get this question, you don't have to solve it using substitution or elimination. You just use your graphing calculator. Let's do the second question. Model and solve a situation with a system of equations. So we're using applications like word problems to solve using system of equations. So Steven loves to challenge his friends with puzzles. He comes across a website that offers online interactive puzzles, but before he is allowed entry to the site, Steven is presented with the following problem. Do you like puzzles? Well, prove your worthiness by solving this conundrum. Determine two integers such that the sum of the smaller number and is plus twice the larger number is 46. So when I read word problems, I always try writing what my variables will be. So x plus 2y is equal to 46. And then it says square of the smaller number is decreased, which means minus 3 times the larger number, 3y is equal to 93. So x squared minus 3y is equal to 93. Now, I can either use substitution or elimination to solve this question. Remember, my smaller number is x, and my larger number is y. So, this is my first equation, this is my second equation. If I want to solve using elimination, I can multiply this by 3 and the second equation by 2. Because remember, when we do elimination, we always want to eliminate the y value. So this would be 3x plus 6y. 46 times 3 is 138. And then 2x squared minus 6y is equal to 186. So I can just, because the signs are different, I just add these equations together. So 3x plus 6y is equal to 138, and 2x squared minus 6y is equal to 186. So when I add them, it's still negative, right? 6y minus 6y is 0, and then you have 2x squared plus 3x. Remember, they're unlike terms because x squared and x1. If you do get confused, an easy way of doing this is just writing 0x and 0x squared over here, because then it'll be 2x squared plus 3x is equal to 138 plus 186 is 324. And then you need to subtract 324 on both sides to get 2x squared plus 3x minus 324 is equal to 0. Now, you have this, you'll have to find the value of x. This doesn't have any product sum factor. So if we cannot do product sum factor, what's the second way we can solve a quadratic equation? Quadratic formula, right? So a is 2, b is 3, and c is negative 324. So substituting it into my quadratic formula, it'll be negative 3 plus minus 3 squared minus 4a, which is 2, and c, which is negative 324, divided by 2a, which is 2. You can put all this in your graphing calculator, and you'll get negative 3 plus minus 2601 over 4, and then square root of that is negative 3 plus minus 51 over 4. Now remember, you have two solutions to it, one with the plus and one with the minus. So negative 3 plus 51 over 4, negative 3 minus 51 over 4. Put that in the calculator, you'll get 12, and then you'll get negative 13.5. So that's just your x values. You're not done yet though. You'll have to find your y values as well, because systems of equation, you have to find your y value. Now, so they have said the smaller number followed by the larger number is your access code. So we'll just disregard this because in this we can just put whole numbers, right? So smaller is 12. We'll substitute this in any of our equation. We can either do 1 or 2. So let's just do 1. So 3 times 12. So this was my first equation, right? So 12 plus 2y is equal to 46. Subtract 12 from 46 is 2y is equal to 34. Divide 2 on both sides and you get y is equal to 17. Okay, and you just put 17 over here, and that's your answer. You can also check your answer using a graphing calculator. If you choose to do it with substitution, all you need to do is you can use either your first equation or second equation to isolate y. So let's use my first equation to isolate y. X plus 2y is equal to 46, right? So subtract x on both sides and you get 2y is equal to 46 minus x. Divide 2 on both sides and you get y is equal to 46 minus x over 2. And then you can input that in your second equation, right? And then find your answer. Because it's fraction, I would rather do elimination to reduce the chances of making a mistake. Now, I want you guys to try these your turn questions by pausing the video, and then we will go over it. Okay, so the your turn question number 1. Determine the two integers that have the following relationship. Twice the first integer, so 2 times the x, is increased by 14 and it equals the second integer y. So my first equation will be 2x plus 14 is equal to y. And then the second integer is increased by 1 and is equal to square of the first integer. So we have y plus 1 is equal to x squared. Now we need to solve them using algebra. So we can use substitution if you guys want for this one. Doesn't matter, you can also do elimination. So the first thing I'll have to do is I will have to find the y value. So I already have the y value. I'm going to put this in over here. So I have 2x plus 14 plus 1 is equal to x squared. So it's going to be 2x plus 15 is equal to x squared. Subtract 2x to have everything on one side, right? So we have 0 is equal to x squared minus 2x minus 15. And then we can use product sum factor for this one. Product is negative 15, sum is negative 3. Your factors will be negative 3 and 5. Okay, so because we have coefficient of 1, it will just be x minus, your sum is negative 2, so it has to be negative 5 comma 3. So it'll be x plus 3 and x minus 5, which will give you x is equal to 3 and positive 5, negative 3 and positive. Okay, so now that we have that, we're not done yet. We'll also have to find the y value. So we can sub it in 1, right? Sub in 1, and we get 2x, which is negative 3, plus 14 is equal to y. So it's negative 6 plus 14, and that's 8 is equal to y, right? So it'll be negative 3 comma 8. And then sub in 5. So 5 plus 14. Y, I'm just using the first equation again. So 10 plus 14 is 24 is equal to y. So my value will be 5 comma 24. So those are my two answers. And then you can verify this by subbing it in to both the equations. So because we have two answers and two equations, how many times will we have to verify this? 4 verifications. Okay, let's do the next question. So a model rocket is launched from a field. The height of the rocket, y in feet above the ground. So y is the feet above the ground. So your y-axis would be the height, and x is seconds, so it will be time. X will be your time. Your equation is given. From the 10th floor of the nearby building, a boy goes to look straight out of the window when he hears the rocket fired. The boy's line of sight is at 100 feet, so we know that over here y is equal to 100, right? So the first question was label each axis. We already did that. Height and time, in feet and in seconds. If the boy took 2 seconds to get to his window, will he be able to see the rocket on its way up? So the way we will figure this out is he can only see the rocket if he is over here at y is equal to 100. So we can use our graphing calculator for this. So y, we'll put in our equation. We have negative 16x squared plus 177x plus 4, and we graph it. I just need to change my window settings, so it'll be, let's do, well, 500. Now I can see it. Let's change my x to maybe 20 and graph it. Okay, that looks better. Now y2 can be 100 because that's my line of sight, right? You can see that. Now let's do second trace 5. That's my first curve, and this is my second, and this is my guess. So it says that at 10.5 seconds I'll see it, but the guy is going at 2 seconds, right? So I need to find my first point of intersection. Second trace 5, that's my first curve. Second curve, that's my guess, and x needs to be 0.6 seconds, right? If he goes at 2 seconds, he won't be able to see it. So no, because the rocket is at 100 feet at 0.6 seconds, but the boy goes up to the window at 2 seconds, right? So I did that using second trace 5 and setting y to as 100. You could also do just second trace value and figure out x is equal to 2 and if it will be at 100 feet or not. So if it's not at 100 feet, that means he will miss the rocket. Part C says from when the rocket was fired, how many seconds will have passed when the rocket reaches the boy's line of sight on his way down? So we already figured that out when I was doing the point of intersection for the first one, right? So second trace 5, same thing, you just go closer to your second point of intersection. It's your line, and it's 10.5 seconds. So it'll be your second x intersection, which is 10.5 seconds. Easy, right? You guys also did these types of questions in last unit, right? This is a challenge question. It's not that difficult though. So let's try doing it. Sum of the square of the two numbers is 74. So x squared plus y squared, you can say those are your two numbers. Difference of those, x squared minus y squared, is 24. These are my equations. What are the two numbers? We can use substitution or elimination for this. Elimination might be actually better, right? Because we already have different signs. So we add. Let's add 1 and 2. So x squared plus y squared is equal to 74. X squared minus y squared is equal to 24. Add them. We get 2x squared 74 plus 24 is 98. Divide both sides by 2 because we want to isolate our x. So x squared is equal to 49. Square root both sides. You get x is equal to 7. Is that it? No, it's plus minus 7. Always remember that. Don't forget about the negative, right? Now that I have that, I'm not done yet. I still need to find my y value, right? So we can sub it in 1 or 2. Let's do 1. Doesn't really matter. So 7 squared plus y squared is equal to 74. 49 plus y squared is equal to 74. Subtract 49 on both sides. 74 minus 49 is plus 25. Yeah. Square root both sides. You get y is equal to plus minus 5. Don't forget about that. Let's do the same thing for negative 7. So if we do it for negative 7, it's going to be positive 49, right? Which leads us to the same equation, right? Because negative 7 squared and positive 7 squared is just 49, right? So you'll get the same answer. If you're not sure what I mean by that, you can solve it again, right? Negative 49. You'll get y squared is equal to 25. Square root both sides, and you'll get y is equal to plus minus 5. So it's the same answer, right? So your final answer is going to be x is equal to plus minus 7 and y is equal to plus minus 5, and that's it. Okay. You can also substitute by finding the y value. But you might have a square root. So if I do use substitution, it's going to be isolate for y. So it'll be x. Let's use this equation. X squared plus y squared is equal to 74. Subtract x squared. You get y squared is equal to 74 minus x squared. Square root both sides. And then you put this in your second equation and solve it using that.